Hello students, welcome to my channel Math Magic. If my video helps you study or improve the subject in mathematics, so watch my video more and more times and share all my videos to all of your friends, like it and subscribe it. Okay, so let's start today's class. Today we will discuss about relation and functions. Okay, so today we will discuss about relation, class 12 chapter. Okay, so first of all, what is relation? So relation on set A and B. Let A and B be two non-empty sets. Then a relation R from set A to set B is a subset of A cross B. That is, relation R is a subset of A cross B. Okay. Now, next is here the subset R is derived by describing the relationship between the first and second element of the ordered pair in A cross B. Okay, the second element is called the image of its first element. Okay, next is domain, range and codomain of a relation. Listen carefully. Let us consider the relation R from set A to set B. That is, R is a subset of A cross B. Then the set of all first element of the ordered pair in R is called the domain of relation, and the set of all second elements of the ordered pair in R is called range of the relation. Okay, and the set B is called codomain of relation. Clear? Now come to the next type of relation on a set. Type of relation, that means how many type of relation are there? Number one, reflexive relation. See carefully. Number one, reflexive. Reflexive relation. Reflexive relation. So what is reflexive relation? Relation R in a set A is called a reflexive relation if A comma A belong to R. Okay, A comma A belong to R for every A belong to capital A. Okay, I repeat, what is reflexive relation? Relation R in a set A is called reflexive relation if A comma A belongs to R for every A belongs to capital A. Okay, next is symmetric relation. Number 2 is symmetric relation. Symmetric relation. So what is symmetric relation? Okay, listen carefully. Relation R in set A is called symmetric relation if A comma B belongs to R. If A comma B belongs to R implies that B comma A belongs to R. Okay, listen carefully. I repeat, what is symmetric relation? Relation R in a set A is called symmetric relation if A comma B belong to R implies that B comma A belongs to R for every A comma B belong to capital A. Okay, that is symmetric relation. Now number 3 is transitive relation. So what is transitive relation? So transitive relation, okay, listen, what is transitive relation? Relation R in a set A is called transitive relation if A comma B belongs to R, A comma B belongs to R and B comma C belongs to R implies that A comma C belongs to R. Okay, I repeat, A comma B belongs to R and B comma C belongs to R and implies that A comma C belongs to R for all A comma B comma C belongs to capital A. That is transitive relation. Okay, so there are three types of relation. Number one, reflexive relation. Number two, symmetric relation. And number three, transitive relation. Okay. Now the fourth one. Fourth one is listen carefully, equivalence relation. So what is equivalence relation? See, listen carefully. So what is equivalence relation? Okay, see carefully. Equivalence relation. What is equivalence relation? Equivalence relation, a relation R on a set A is said to be equivalence relation of A if it is reflexive, symmetric as well as transitive. Okay, I repeat, what is equivalence relation? A relation R on a set A is said to be equivalence relation if it is reflexive, symmetric and transitive. Okay, that means satisfy all the three conditions. That relation is called equivalence relation. Okay, so listen carefully. Reflexive relation, A comma A belongs to R, that is reflexive relation. Symmetric relation, A comma B belongs to R implies that B comma A belongs to R, that is symmetric relation. Next transitive relation, A comma B belongs to R and B comma C belongs to R implies that A comma C belongs to R and A comma B comma C belongs to capital A, set A. That is transitive relation. And what is equivalence relation? That means a relation which satisfies all these three conditions. That means reflexive, symmetric and transitive. That relation is called equivalence relation. Okay. Look. Now give some examples. Okay. See examples number 1. Okay, listen, if R equal to, example number 1, listen carefully, if R equal to, that means a relation R equal to x comma y such that x plus 2y equal to 8, x plus 2y equal to 8, okay, x plus 2y equal to 8 is a relation on a set of natural numbers. Then write the domain, range and codomain of R. Okay, if R is x comma y such that x plus 2y equal to 8 and x belongs to capital N, that means set of all natural number, then write the domain, range and codomain of R. Okay, now see, first of all we find the relation. So see carefully, we can write therefore R equal to, okay, set of all natural number. So see carefully, when x equal to 1, okay, see x plus 2y equal to 8 or 2y equal to 8 minus x or y equal to 8 minus x divided by 2. Okay, now find the sets. So here is we put x equal to 1. So 8 minus 1, 7 by 2, not possible, that is not natural number. So x equal to 2. So what we will get? X equal to 2. So 8 minus 2, 6. 6 by 2, that is 3. We get first one, 2 comma 3. Then put x equal to 4. So 8 minus 4, 4. 4 by 2, that means 2. So if we put the value of x is 4, we get 2. Value of y is 2. Now put the value of x is 6. So x is 6. So 8 minus 6, that is 2. 2 by 2, that is 1. Okay. So we get 3 sets. 2 comma 3, 4 comma 2, 6 comma 1. If we put 8, the value of x is 8. So 8 minus 8, 0, 0 by 2, 0. 0 is not a natural number. Okay. That is why r equal to 2 comma 3, 4 comma 2 and 6 comma 1. This is the relation. We get the relation. Now the question is find the domain, range and codomain. Okay. So domain. First of all, domain. Okay, listen carefully. All the first element, that is 2, 4, 6. All the first element is called domain. So domain equal to 2, 4, 6. Now range. Range equal to all the second element is called range. That is 3, 2, 1. 3, 2, 1. That is range. Okay, and codomain. Codomain equal to, okay, codomain equal to all the value of y, all the value of y, that is codomain. So here is codomain r equal to, all the natural number. Okay, we write r equal to all the natural number, that is codomain. Okay, clear everyone? So this is example number 1. Let's see carefully. Now come to example number 2. Listen the question first. Example number 2. The question is, example number 2. The question is, determine the relation are reflexive, symmetric and transitive. Okay, determine the relation. This is symmetric, reflexive or symmetric or transitive. Okay, now the relation R in a set of all natural number is defined by R equal to x comma y, R equal to x comma y, such that x plus y equal to x plus y, y equal to x plus 5, y equal to x plus 5, and another condition is x less than 4, x less than 4. Okay, so this is a relation. Now the question is, the relation is, find the relation is reflexive, transitive or symmetric. Okay, so one by one, first of all find the relation. So listen carefully. Here r equal to x comma y, r equal to x comma y both are natural number, and y equal to x plus 5. Okay, so first of all we find the relation r. Okay, so y equal to x plus 5 and x less than equal to 4. So what is the value of x? X equal to 1 or x equal to 2 or x equal to 3. Okay, remember one thing, that is x and y both are natural number, that is given on the question. So when x equal to 1, so put x equal to 1, y equal to 1 plus 5, that is 6. Okay, then put x equal to 2. So what we will get the value of y, that is 2 plus 5, that is 7. Okay, so 2 comma 7, next order here. And third one is x equal to 3. So we get 3 plus 5, 8. Okay, this is, we get the relation. Okay, now check this relation is reflexive or symmetric or transitive. Check one by one. First of all, check this relation is reflexive. First one, see 1 comma 1 not belongs to R. Okay, 1 comma 1 or 2 comma 2 or 3 comma 3 not belongs to R. That means this relation is not reflexive relation. Okay, now come to question number part number 2. This relation is symmetric. Okay, check, this relation is symmetric. 1 comma 6 belong to R, but 6 comma 1 not belong to R. That means this relation is not symmetric relation. Okay, now come to third one. The relation is transitive. Check part 3. Relation is transitive. See, 1 comma 6 is there, relation R, but 6 comma anything not in R. Okay, so see carefully, A comma B belong to R. Okay, B comma C not belong to R in this relation, and A comma C there is also not belong to R. That means this relation is not transitive relation. Okay, so in this relation we do not find this situation. Okay, look, now come to example number 3. Okay, listen question number 3 first carefully. Listen the question first. Question number 3 is, show that the relation in the set A of all triangles given by R equal to T1 is to T2, T1 comma T2, sorry, not is to T1 comma T2, such that T1 similar to T2, such that T1 similar to T2. Okay, so similar to T2 is an equivalence relation. Okay, this is the first one. Show that the relation R in a set A of all triangles given by R equal to T1 comma T2 that means triangle 1 comma triangle 2 such that triangle 1 similar to triangle 2, okay, is an equivalence relation. And second one is consider three triangles T1 with side 3, 4, 5. Consider three triangles T1 3, 4, 5. T2, the three side length of three sides triangle T2 5, 12, 13, 5, 12, 13, and T3, the triangle 3, the length of three sides are 6, 8, 10, 6, 8, 10. Okay, the question is with the sides consider three triangle T1, T2, T3. The three sides are given. Are which triangles among T1, T2 and T3 are related? Which triangle among T1, T2 and T3 are related? Okay. Now come to one by one. First of all, prove this one. This is required to prove this is equivalence relation. That means this equation satisfies three conditions. Number one, reflexive relation. Number two, number one reflexive. Number two, symmetric. And number three is transitive. Okay. First of all, we prove one by one condition. Okay. After that, we can say that this relation is equivalence relation. Okay. Now first one, consider T equal to T is any triangle A, given that A is all the triangles in set A. Okay. Given that A the set of all the triangles. Okay. Okay, A, given that A is set of all the triangles. Okay, now see here T belongs to A. T, that means triangle belongs to A. Any triangle belong to A. Okay, any triangle belong to A. Since T and T are similar, and since T similar to T and T both are same triangle, that means must be similar. So we can write that. So it is clear that, or we can write that T comma T belong to R. So T comma T belong to R. Okay, we can write that T comma T belongs to R. Okay, so R is reflexive. So we can say that R is reflexive. R is reflexive. Okay. Next, part 2. First one is we proved reflexive triangle. Okay. Now second one is symmetric. See, T1 and T2 both are in triangle A. T1 and T2 both are in relation R. Okay, listen carefully. T1 and T2 both are relation R. Okay, now T1 similar to T2 given. Now same as T2 similar to T1. Clear? T1 triangle 1 is similar to triangle 2. So we can clear that T2, that means triangle 2 similar to triangle 1. Okay. So we can write that therefore T1 similar to T2 implies that T2 similar to T1. Okay. So we can write therefore T1 comma T2 belongs to R implies that T2 comma T1 belongs to R. Okay. T1 comma T2 belongs to R implies that T2 comma T1 belongs to R. That means R is symmetric. That means R is symmetric. Okay. That means R is symmetric. So first one is proved reflexive. Second one also proved that is symmetric. Next is required to prove. Okay. Next is required to prove reflexive. Check carefully. Consider any triangle T1, T2 and T3 belongs to A. Consider any triangle T1, comma T2, comma T3 belongs to A set A. Okay. Now see what happened. T1, comma T2 belongs to R. That means T1, comma T2 belong to R. That means relation. Then T2, comma T3 belongs to R. Okay. Now see T1, comma T2 belongs to R. T2, comma T3 belongs to R. Okay. That means we can write, and T1, see, T1, T2 similar, same as T2, T3 similar. So we can write T1, T1 similar to T3. Okay, so T1 comma T3, T1 comma T3 obviously belong to R. That means this relation is symmetric relation. Okay, this relation is symmetric relation. Okay, that means this relation satisfied all the condition reflexive, symmetric as well as transitive. Sorry, not symmetric, this is transitive relation. Okay, transitive. Transitive relation. So we can say that this relation is a equivalence relation. Okay, now next part is T1 3, that means triangle 1, 3 sides 3 4 5, triangle 2 3 sides 5 12 and 13, and T3 the third triangle, length of 3 sides 6 8 and 10. Listen carefully. Look T1 and T3. Okay, look T1 and T3. 3 by 6 is equal to 4 by 8 is equal to 5 by 10. That means all the relation is half. Okay, so 3 by 6 half equal to 4 by 8 half, and 5 by 10, that is also half. So here is T1 and T3 as related to each other, not T2. Here, look. Now come to the next example. Example number 4. Listen carefully. Example number 4. Listen carefully. Listen the question first. Let A equal to x belong to z. Let A equal to x belong to z. Z means integer. Okay. X belong to z such that 0 less than equal to x less than equal to 12. Okay. 0 less than equal to x less than equal to 12. Show that R equal to relation R equal to, show that R equal to A comma B, R equal to A comma B, A comma B belongs to A comma B, such that A comma B belongs to R, belongs to A, okay, and A comma B, A mod of A minus B, mod of A minus B, mod of A minus B is divisible by 4. Divisible by 4. Here, okay, look, first A is this. A is a set of all integers, and value of x is 0 to 12. Find R equal to A comma B such that A, B both are in set A, and mod A minus B is divisible by 4. Okay, is an equivalence relation. Prove that this relation is an equivalence relation. Okay, that means here we must be proved that is reflexive, that is transitive, that is reflexive, that is transitive, and that is symmetric. Okay, that we say that this relation is equivalence relation, and then find the set of all the elements related to 1, and also write the equivalence classes 2. Okay, come one by one. First of all, prove that this relation is an equivalence relation. Okay, so come one by one. Given that R equal to relation R equal to, okay, R equal to A comma B such that A and B both belongs to A, and mod of A minus B is divisible by 4. Okay, so listen carefully. Since A minus A is divisible by 4, listen carefully. A minus A is divisible by 4. Divisible by 4, A minus A. That means A minus A, two same number, the minus is 0. So 0 is divisible by 4. So A and A is any number. So A minus A is divisible by 4. So A, that implies that A comma A belongs to R. Okay, A comma A belongs to R. That means R is reflexive. So we can say that R is reflexive. R is reflexive relation. Okay. Next is required to prove the R is, let A comma B belongs to R. Next is A comma B belongs to R. Okay, listen carefully. A comma B belongs to R, where A and B both are belongs to A. So A minus B is divisible by, so A minus B mod of A minus B, obviously mod of A minus B is divisible by 4. Okay, mod A minus B is divisible by 4. So we can say that B minus A, mod of B minus A is divisible by 4. Divisible by 4. Okay, mod of B minus A is divisible by 4. Okay, so clear. So B comma A belong to R. So listen, A comma B belong to R. So B comma A also belong to R. That means this relation is R is symmetric. So we can say that R is symmetric. Okay. So first of all we prove R is reflexive. Then we prove R is symmetric. Last one required to prove R is transitive. Okay. How to prove it? See carefully. Let A comma B belongs to R and B comma A belongs to R. Sorry, B comma A, not B comma C belongs to R. Okay. A comma B belongs to R and B comma C belongs to R, where A comma B comma C both are belongs to in set A. Okay. Now see, so A, listen carefully, A minus B, mod of A minus B is divisible by 4. Mod of A minus B is divisible by 4. Okay. And mod of B minus A, B minus C, mod of B minus C, mod of B minus C also divisible by 4. Okay. So mod of A minus B is divisible by 4. Mod of B minus C is divisible by 4. Okay. So we can write A minus B, listen carefully, A minus B, mod of A minus B equal to 4k1. Okay. And mod of B minus C equal to 4k2, because these two are divisible by 4. Okay. So see, A minus B equal to plus minus 4k1 and B minus C equal to plus minus 4k2. Okay. So just add these two. This one, add this one. Okay. So what happened? So if we add 2, 2 we get, see, A minus B plus B minus C, A minus B plus B minus C equal to plus minus 4 into K1 plus K2. Here BB cancel, so we get A minus C equal to plus minus 4 into K1 plus K2. Okay. So mod A minus C equal to 4k1 plus k2. So this one must be divisible by 4. Okay. This one, that means mod A minus C is must divisible by 4. Okay. So listen carefully, A comma B belongs to R. So B comma C belongs to R. So it is clear that A comma C also belong to R. Clear? Clear? So we can say that R is transitive. Okay. So we can say that R is transitive. So R is reflexive, R is symmetric, R is transitive. So this relation is a equivalence relation. This relation is a equivalence relation. Why? Because all the three conditions satisfied here. This is very important and comes on the board exam. Okay. So this is very example. Now come to the second one. The second question is find the set of all the elements A related to 1. Okay, set of all the elements A related to 1. So see carefully, related to 1, that means A minus B divisible by 4. Okay, so there x, the value of x is 0 to 12. So if we relate it to 1, that means A is 1. So divisible by 4, so A is 1, that means B is 5. 1 minus 5, that is 4, divisible by 4. So first number is related to 1, that is 5. Okay, then second one is 9. 1 minus 9, that is 8, divisible by 4 also. And one thing, first B is also 1. 1 minus 1 is 0, that is also divisible by 4. So we get 3 number. So I repeat also, the set of elements in A related to 1, that is 1, 5, 9. Okay. Now the third one is the equivalence classes of 2. Okay, that means set of element A related to 2. Okay, equivalence classes of 2, that means again one thing, you satisfy this condition, A is 2. So what is the value of B? When A is 2, B is 2, 2 minus 2 divisible by 4, 2 minus 2, 0 divisible by 4. Okay, and next one is 6. 2 minus 6, that is 4, that is also divisible by 4. And last one is 10. So 2 minus 10, that is 8, divisible by 4. So the answer is the equivalence classes 2. That means set of elements A related to 2, that is 2, 6, 10. Got it? See carefully. Thank you, students.